is Anastasios Extos, and I'll be very happy to present to you even through video, as it's currently almost midnight in the UK. The methodological steps that we followed for structural inspection in the affected area. Our team was comprised by structural engineers, some of those also member of GEAR, coming from the University of Bristol, NTUA Athens, University of Thessaloniki in Greece, that's the Hellenic Association of Earthquake Engineering. So we'll be showing you some slides from the inspection procedure, as well as some indicative results and some ideas for future inspection. So, in short, the way that we proceeded was the following. First of all, this was a two-stage field mission, in the sense that geotechnical experts led by George Milanakis visited the site in mid-September, quite after the event. Structural engineers followed early October. Now, the question always has been, as you see the map of the visit, of the places that we visited, but the question is always where to go first. One way to deal with this is to install or download the Copernicus files to see a first estimate of the collapsed buildings. But also you need to collaborate with, and this is what we did in fact, with the GEAR people and the other survey groups, to make sure that there is no significant overlap between the places that we were planning to visit and the places that had already been inspected. Having done that, we started a campaign of building by building inspection to perform a complete observation of the area and identification of the most interesting from scientific or engineering point of view in the areas that were most important to be inspected. Geolocalization of photos is something very important in order to be able to deploy the information on the map and then make any correlation with in terms of spatial distribution of excitation and response. So coordinates are saved and geotagged, photos are shot by all members of the mission, and then in post-processing these are being further cleared. But the idea is that we have either a GPS device with us to complement the photos who have embedded GPS tagging anyway. So there's always a duplication of effort in terms of the information that we gather and the geospatial information that we collect. Then it was very important to get familiar with Italian quick inspection form, which is based on the IDIS form. In short, this is a general approach for post-earthquake damage inspection and safety assessment of structures, dealing with the structural system, the material, quite detailed examination of local damage, as you can see in the figure below, soil conditions, various roofs, foundations, and any other kind of damage that is being identified. So the Italian inspection form was transformed into an access database for tablets, which were also equipped with GPS so that they could trace the signal of the exact position. And every building got a unique ID for further processing. Naturally, we also did it on pen and paper just to play safe in case that there was any error in the database or the GPS tagging. It's always a good way to play safe and have some redundancy with the results. Typologies of the structure. Of course, this is an area where most of the structures were not really seismically designed and constructed, and they were pretty much ductile. And the reason was that most of them were quite old buildings, with the exception of those who had been retrofitted after the 1997 Amatrice earthquake, mainly in the northern part of the affected region. So the two main typologies that were identified were masonry buildings and reinforced concrete buildings, let's say at a ratio of 4:1 or so. And this was also reflected in the data, structural data that we've got. Another important aspect of the work as a following stage is to correlate the post-quake with pre-quake photos that are available in Google Street Views. And this is very useful, particularly when we need to understand a little bit better of the structural system of a partially collapsed structure or even a totally collapsed, because otherwise there is no way to identify the number of stories, the area, the footprint, and the structural system. So this is very, very important to engage with Google Street View. You can see here some before and after images, which were pretty handy in dealing with this aspect. And then this is something that is not really described in the Italian inspection sheet, even though the information is quite extensive in terms of local damage. One needs to define an algorithm or some weighting scoring to assess a global damage state for the structure, and this is what we did automatically. Then shape files containing the surveyed building footprints and associated data from the database were generated, showing the distribution of the various damage states in space. And in some specific cases, quite selectively, about 20% of the sample, the ideas was retrospectively completed based on the existing photos, pre-quake images, building footprints, and engineering judgments. So in areas that we needed just few buildings to populate our sample better, we retrospectively used photos of other groups that did not exist. They did not contain detailed information, but as I said, by engineering judgment, we managed to do so. Another step was the validation of the database, particularly in the Amatrice red zone, because of course our mission was was applied 1 month earlier than the event, which means that sometimes it was difficult to identify whether a collapsed building was immediately collapsed after the earthquake, or this was a result of a demolished, partially collapsed building. So this again involved previous images of the Copernicus database to make sure that whatever we record in the database as full collapse was earthquake-triggered full collapse and not man-made. Now there are a few other aspects that are still open, like which shake maps to use. Perhaps better than we do, that INGV tends to underestimate the magnitude of the earthquake, and this is also reflected in the distribution of the intensity measures. And then another question is how reliable is Copernicus' first assessment, given that in some cases the roof from the satellite seems to correspond to a partially or collapsed building or a safe building, but at the same time there is some hidden information that you can be inspected by the satellite. So we are doing this correlation between the on the ground, let's say, field inspection and the prediction. And another very important aspect is whether we have adequate data to perform empirical fragilities. This is something that we're still working on, populating the data, and I think that very soon we will be able to compute these empirical fragility curves, which is quite handy information based on the existing data. Last but not least, the very recent earthquake and the cumulative damage and partial collapse or total collapse of the multiple events. Given the extent of the database that we've got, I think it's very, very useful to be able to have the evolution of damage for different events. And this has a very significant scientific importance in our opinion. So these are the acknowledgements of the various people participating under different schemes. And having said that, I would like to particularly thank Dr. Raffaele Derisi for his excellent work in pre and post processing of most of the data that you've seen. So thank you very much for your attention.